Today we start chapter 2. Properties of functions. So we start with the definition of a function. Definition. A function is a rule that assigns to each element from one set exactly one element from another set. So here is how we can present this. Suppose we have a set A and there is a set B. So for every element from A, there is one output. For every element A, there is one output. A. Two different elements from A can go to the same element in B. So definition does not prohibit it. So for every input, there is exactly one output. Input, one output. Input, one output. That's a definition of it. So functions, the set A is called domain, and set B is called the range. So domain is the set of all inputs. Range is set of all outputs. So the mappings, we're going to use letter F, for example. F is a mapping. Mapping is the same as rule. Okay. If we call it X input, this is Y out. Also, X is called independent variable. Independent variable. And Y is called dependent variable. And here's the notation we're going to use. Y equals f of x. Means y is a function of x. So we can give functions by a rule or by an analytical formula. Here it is example. Example, y equals x squared. X input, y is output. So what is the domain? What kind of numbers I can plug in? So domain of this function is any real number, entire number line. How about the range? So this is we're going to call domain. This is a range of that. What's the range of non-negative real numbers? You cannot get negative. You can get zero. So we can also use f of x equals x squared. In this notation, you can give the input. So f of 0 equals 0. F of negative 2 is 4. F of positive 2 also 4. So two different elements, minus 2 goes to 4. But it's okay because every input has one output. If you graph it, it's a parabola. So y equals x squared. Vertex at the verge. So here's another example. F of x equals square root of x squared minus x minus 2. So let's find domain of it. To find domain of this function, the quantity and the square root must be greater than or equal to 0. If it's negative, we end up complex numbers, which we're trying to avoid. So the solutions of this, you know how to solve inequalities. So here it is. We're looking where this. So here it is. Everything here and here. So domain of this function from negative infinity to negative 1 bracket union bracket 2 comma infinity. Of course, the range will be non-negative real number. It is important to find out if the graph represents a function. So I'll give you the vertical line test, so-called vertical line test. if a vertical line intersects a graph in more than one point, then the graph is not the graph of a function. So every vertical line has to cross graph in no more than one point. So in the previous example, we had y equals x squared. Represents a function. Because it passes vertical line test. So any vertical line crosses no more than one point. The second one was passes vertical line test. So it is a function. Let's give definition of even and odd function. F of x is called an even function if for any x from the domain of f, the symbol means any. Negative x also belongs to domain of f, and f of x equals f of negative x. So in our example, example 4, f of x equals x squared is an even function on entire number line. Definition: f of x is called an odd function if for any x from the domain, negative x also belongs to domain, and f of x equals negative f of negative x. Example: f of x equals x cubed on entire domain, real numbers. Then negative x cubed equals negative x cubed. Can you write this? F of negative x equals negative f of x. So it is odd. It is an odd function. Also, another word, the power is even. You get even function on its appropriate domain. Odd, power is odd on the entire number line. You have to choose domain. Don't forget this condition. For any x, negative x also must be in your domain. So graphs of even functions symmetrical by the y-axis. The graphs of the odd functions symmetrical by the origin. So next is quadratic functions. Before the quadratic, let's remind the linear function. Linear function. F of x equals ax plus b. A and b are real numbers. Domain of it, all real numbers. And the range of it, all the real numbers, if a does not equal 0. If a is 0, it's a single number. You get a constant function. There is a definition of quadratic function. Quadratic function. F of x equals ax squared plus bx plus c, where the a, b, c are real numbers. And a is not 0, otherwise it's linear. So what's the domain of this function? All real numbers. By the way, it is a general fact. Any polynomial function has entire domain of real numbers. About the range. Range is square root of, bracket d negative d over 4a comma infinity if a is positive, and negative infinity comma negative d over 4a if a is negative. So in this case, functions, the graph, it's a parabola, opens up. In this case, opens down. Let's remind the vertex v, negative v over 2a, negative d over 4a, vertex of the parabola. We did this in Algebra 2, so I hope you remember. You can find out in your textbooks. So how the graph of it? So let's bring to the graphing form. I can write graphing form of y equals ax squared plus bx plus c. This is called standard form. How to rewrite this? It's a times x plus b over 2a squared minus b over 4a. That's a graphing form. So when x equals negative b over 2a, the y equals negative b over 4. Again, if a positive, parabola opens up. If a is negative, opens down. So in this case, this is highest point. In the first case, lowest point. So the vertex minus b over negative b. So how to get the graph of this function? You take a standard function a x squared and move horizontally negative b over 2a units. If it's positive, to the right. If it's negative, to the left. Then lift up or down. If this is positive, it's vertical shift. If it's negative, it's horizontal. So the shape of this parabola, let's call this is 1, 2, is the same as shape of 3. So these two graphs, parabolas, they have the same shape. In order to get this one go through the origin. In order to get graph 2, you move this b over 2, negative b over 2 units, left and right, depending if it's positive, and up and down, negative b over 4a. If it's positive, up. If it's quantity, negative, down. So it is shifting, okay, horizontal, vertical shift. So let's see some problems, okay? So I'll do exercise number 9 from your textbook, 2.2. Let me do it. Complete this square and determine the vertex of each of the following. So y equals 3x squared, 9x plus 5. So in this case, your A is 3, B is 9, C is 5. You can plug it into the vertex formula, or you can use the completing the square. Let's do it. I'm going to factor out 3. I get x squared plus 3x plus 5. Let's make a perfect square. X squared 3x. Take half of it. Half of the 3. Square it. Add and subtract. We're adding and subtracting at the same time. So what do? These 3 terms, they will give you perfect square. So I get 3 times x plus 3 halves in parentheses squared. And here, minus 9 over 4 plus 5. Or expand this. Multiply by 3, you get negative 27 over 4 plus 5 is 20 over 4. So I get 3 x plus 3 halves squared minus 7 over 4. So here's the vertex, negative 3 halves. This is graphing form. Negative 7 over 4. Since a equals 3, positive, the parabola opens up. This is the vertex. This is a vertex. Okay. Next topic, section 2.3, polynomial and rational functions. Definition. F of x equals a sub n, x to the n, a sub n minus 1, x to the n minus 1, and so on, a sub 1, x to the first plus a sub 0, with a sub n equals 0. N is a natural number. Let's put whole number. Whole number. Remember whole numbers? 0, 1, 2, and so on. Where the a sub k are real numbers. This means belongs to symbol in, where the k 0 through n, those are called coefficients, is called a polynomial function of degree n. So let's see examples. If n equals 0, then we get f of x equals a sub 0 x to the 0, which is a sub 0, constant function. Constant function. What is the domain of it? Domain of it, all real numbers. By the way, domain of entire polynomial function is all real numbers. I don't have to tell this anymore, because you can plug in any real number. So how the graph looks like? A sub 0 does not equal 0. It's horizontal line. Y equals a sub 0, horizontal line. Second example, n equals 1. Then you get f of x equals a sub 1 of x plus a sub 0. A sub 1 is not 0. It's a straight line. Y equals a sub 1x plus a sub 0. If a sub 1 is the slope, y sub 0 is the y-intercept. So, by the way, what's the range here? Range here is a single number, a sub 0. The range in the second one, again, domain all real numbers. I'm not going to mention it. Range of this function is all real numbers also, because the shadow of this line onto y-axis covers entire y. Next one, let's take n equals 2. Then you get f of x equals a sub 2x squared, a sub 1x plus a sub... It's a quadratic function. We just discussed this. What's the range of it? Bracket negative d over 4a to infinity if a sub 2 is positive. And parentheses negative infinity negative d over 4a2 if a sub 2 is negative. By the way, d is discriminant. I forgot to tell you over here. D is a discriminant equals b squared minus 4ac. It's called discriminant. Discriminant. I hope you remember this from the algebra. So in this case, discriminant will be b squared, which is a sub 1 squared minus 4 times a sub 2 a sub 0. This is discriminant. I'm not using a, b, c. I'm using a sub 2, a sub 1, a sub 2. And indeed, in this case, parabola opens up. In this case, parabola opens up. So next one, n equals 3. Then you get cubic function, a sub 3x cubed, a sub 2x squared, a sub 1x plus a sub 0. With a sub 3 is not 0. The range of this function is all real numbers. So it behaves as a cubic parabola, y equals x cubed. All real numbers. So what's the conclusion? If you pay attention to example number 2 and 4, so I can answer the question. The range of the polynomial function is entire number line if n is odd. When n is even, it's hard to tell, okay, like quadratic. But if n is odd, the range of polynomial function is all real numbers. So of course, you can use graphing utilities, and I encourage you to use Desmond.com, it's free, or GeoGebra.org. Those are graphing utilities you can download on your smartphone or laptop or desktop. Okay. So now, what is the rational function? Rational function is the ratio of two polynomial functions. So R of x equals P sub n of x over Q sub n of x. P sub n and Q sub n are polynomials of degree n and m respectively. So what is the domain of the rational function? It's all real numbers except the numbers where the denominator equals 0, except then all the x's, which makes q sub m of x 0. From the entire number line, you have to take out the values which make denominator 0. There's example. Y equals 1 over x. It is a rational function, polynomial degree 0 over polynomial degree 1. So domain of it is all the real numbers except the value which makes denominator 0, 0. So it is negative infinity comma 0 union 0 comma infinity. So you're throwing out from the number line. So if you, by the way, the graph of this is called hyperbola. If you graph it, this is what you get. Goes forever, of course. They do not touch x or y. So the asymptotes. What the asymptotes? Asymptotes of rational of any function. So x equals k constant is a vertical asymptote for y equals f of x if values of f of x get larger and larger without bound, when x approaches k. Y equals k is a horizontal asymptote. Asymptote for y equals f of x if values of f of x approach k, when x gets larger and larger. Later we're going to explain this using notion of the limit. Okay, so I'll show example. So y equals 18x over 106 minus x. So x equals 106 is a vertical asymptote. And y equals negative 18 is a horizontal asymptote. Why is it? Denominator becomes 0 when x 106. So when you're very close to 106, this fraction blows up. It's larger, larger, depending, or goes small and small, goes to negative infinity. When x is large, you get the following: 18x over minus x. So cancel x, you get negative 18. So this is, if you graph it, you will see. Okay. So now I'm gonna stop at this point. Then in my next lecture, I'll continue chapter 2.